Okay, so my name is Paul, email address on the bottom. I'm glad everybody came out this morning. This is a rough talk in the sense that we're the first ones after the party. So basically, here's just a quick little picture of a dog saying, yes, this is a dog. No. So Paul, I live in Ottawa. I've been using Asterisk for a few years now. This is my third talk. Last year I did a talk about automating your infrastructure from the ground up. The year before that, I talked about the test suite in Asterisk. So basically today, I hope to talk about the differences of where the stuff that we're working on with queues compared to the existing queues in Asterisk. So obviously, everybody in here, or hopefully everybody in here, has used AppQ or is using AppQ, or they want to use it in a different manner. How's that working out for everybody? Because I'm sure it's not good. Yes, if you haven't heard Jared's joke, you got to go talk to him about this gesture. So AppQ, the thing about AppQ is it's in the Asterisk source code, but there really isn't anybody maintaining it. So there's always this concept of there's a problem in AppQ, but I want to get it fixed. But then you got the people that are using AppQ that don't want it fixed because it's going to break all their logic and all their business on top of it. So who's seen this guy before on the right? I mean, if you haven't, yeah, you're probably in the wrong spot. But life is basically gone and done this presentation about 4 times, I think, right? 6 times of distributed call queues and so on and so forth. And more specifically, distributed call state. So you can see it's kind of a complicated concept because he's going out and he's actually telling you how to provision your PRIs and your phones and your databases and where all that stuff lives and how to replicate it from one to another. It's great. It works. We actually use it today, but the main issue is that the actual once the caller gets into the queue, another queue doesn't know anything about that other queue. So there's no easy way, or as it stands now, there's no way that you can share information of a queue. So if you have 2 callers coming in exactly the same time and they're on 2 different boxes, you cannot do first in, first out across your agents. It's just random, and that's basically the concept of it. And then again, who actually has not seen this dial plan? It's from basically the book, the Asterisk book, and this is how you add and remove your agents from a queue. But the issue is this, again, isn't being distributed across the other Asterisk box. It's all local to the ASDB, and you can hook into the database and kind of pass that through, but you're writing dial plan to control that. And that might be good for the local handset and the agent who wants to log in and log out and pause themselves. But the reality is it's not the agent that's controlling themselves, it's the call center manager who's controlling the agents and where they live and when they log in and log out and see their states and statuses and all that good stuff. Make sure I'm... So you need control. Log your agents in, add your queue members into the queue, delete your queues, edit your queues, update your queues, change dates and times, open operations, emergency messages, all that stuff. Well, how do you do that in Asterisk? Well, you don't. You build something on top of Asterisk to do that. And if we go back to this slide, where does the information live? Well, it lives in a database, but again, you need direct pipes to those databases. And if you have 2 boxes, it's cool, but what if you have 20 boxes or 100 boxes or 30 boxes, or you have a box that comes up for 10 minutes and then disappears because you just don't care about that box. It's only in emergency situations or you're getting hammered. So yeah, so it's all doable, and we ended up doing it. Yeah, so I mean, it kind of works, but what's actually happening with your queue callers and your queue stats and your live stats, and again, I'm hoping everybody's dealt with call center managers because they basically drive the call center. So it's cool that you've gone out and you've implemented this queuing system, but they're always now directly talking to you, trying to get more information out of the queue. And that's great if you have a maintenance contract with them and you want to take responsibility of that queue as your product or your lifeline. But it's also a burden on you for them to come to you and get that information and so on. People just want, they want access to the data, and it's in Asterisk, but there's no easy way to get it. And I'm sure everybody's heard ARI, and that's the next thing, and you can create channels and so on. But that doesn't solve the issue of controlling your agents, controlling your queues, and all that good stuff. So basically, I'm going to just quickly talk about an example that we did for a customer last year after AstriCon. 1 second here. I'm out of water, but. So I'd be curious if anybody has done something like this. I'm sure you have, because nobody ever thinks of the idea first. So we built this little middleware, and it's very thin, that tapped into the Asterisk manager and scraped the events by parsing the message headers, which, if everybody's done it in AMI, they're not the same, they're not consistent. So we actually used StarPy from Python, which is on the Twisted protocol, or the Twisted module, and then we dumped them into a message bus. Oh, Josh, you're the man. Let's give it up to Josh. So yeah, so we didn't want to directly talk to the manager because, well, like I said, we don't want to know where Asterisk is. We just want to go to a bus and get that message. So we created a simple parser that scraped every event that came in, dumped it into the message bus, which was AMQP. And then at the same token, we wrote something on top of that grabbed that information from AMQP and then dumped it into a database because we wanted some records of the call. So again, we had to build another parser to take those records out and dump them into the database. But one of the first issues we had is for whatever reason, we lost a message in the conversion of parsing to dumping to reparsing, and our statistics slowly but surely would start to diverge from what Asterisk is actually saying is happening and what we're actually reporting is happening. Because at the end of the day, we tried to mirror all that information and build it to a format that we could then launch our browsers, our HTML5 browsers, to connect to that message bus to then start populating the real-time stats in the browser to see what the agent is doing, to see who they're talking to, who they're not talking to, when they went on break, when they didn't go on break, when they were paused. Just a simple thing of an agent is paused. Okay, well, what type of pause? Because our client wants to know when they were going to use the restroom because they only allocated X amount of minutes for them to go to the restroom. They want to know when they went on lunch because if they all went on lunch and calls came in, the queue goes backs up. So as we started adding layers upon layers upon layers upon layers, we're now parsing something, taking it, and then we have to reparse it and move it and so on. Add to that, we had to actually add a proxy in front of Asterisk AMI because our developer wanted to just write Node.js and JavaScript directly to the manager, and apparently there's a security, I'm not a web guy, but you can't do that. The browser doesn't let you do that because then you get into like injections and stuff. So we had to basically download this simple Ruby library that proxied. So now all of our traffic is going through this proxy that's a simple one-line command that's running, but it's another performance hit. And then add to that all that, we actually had to write something on Django, which was our database interpreter, which gave us a REST API because, well, the browser can't talk directly to the database. I mean, that might be common sense for everybody, but when we were initially designing and deploying this, I had no idea because I'm not a web guy. So when we got a web guy in, he's like, well, I need an API, and we're like, well, it doesn't exist. So we had to go quickly write something, and of course, you quickly write it, and it doesn't work, or it works just for that specific issue, but then your customer says, well, I need this new feature. Okay, well, you know, that should be like a 4-hour job. Well, it would be a 4-hour job, but we have to, you know, go through all these layers to get all that stuff. But at the end of the day, we got it working, and it surprisingly works well, and it works great. But we always say, well, we don't always say, but the concept is, okay, it works, but we don't really want to change it, because if we change something, it breaks, and it's very difficult to troubleshoot and so on. So yeah, so it works great, but when it works, and like I said, if you have to add a new feature, new stuff, it takes lots of time and energy, and you got to get like 8 people in a room because the web guy has no concept of channels and asterisks or queues or state information, and our message bus guy has no concept of web. And I'm sure we can get guys that are knowledgeable of all that stuff, but I mean, let's face it, you don't want to do. You just want to farm work out to a web guy, you know, or a low-level networking guy and stuff like that. So yeah, so what did we do? So this is where make sure I'm good on time here. So what did we do? So we basically moved everything into Redis, which is where all of our information lives. And why Redis? Well, because it's fast. Hopefully everybody has a concept of Redis or has used Redis or looked to it. It's the hot rage. Well, I don't know. I hear it's the hot rage, but it's super fast. And because it's writing directly to memory, all you got to do is spin up a Redis system with 20 gigs of system RAM, which is cheap these days, right? And it's all fast. It's all real time. So from that Redis interface, there's a parallel database interface, which we use a process to dump anything that we don't care about this instant. So once the call is done, we have an out-of-band process that moves it into the database because you now want to run reports on that information. But you don't want to write directly to the database because there's a performance hit for all that stuff, and everything needs to know about the database. And your queue app really doesn't. The only time they need to know about the database is when they're loading a new agent coming into the picture. So go to some storage configuration to get it, dump it into real time, or dump it into Redis for when it lives and when it pauses, or when it goes on break. But when you log them out, they don't need to be in Redis anymore because, for all intents and purposes, they're gone out of the picture. So all of that. So basically, we built a little RESTful interface that allows us to do that. And that's our single entry point into the whole system. So regardless if you're trying to build dial plan logic to log an agent in or out, or you're trying to change a queue, you just simply curl the information from the dial plan. Or if you want to create a browser to log this in and out, because you're going to use WebRTC and real-time browser, you simply hit the API. You know, I'm not talking about new concepts. Everybody's done this, but the plan is to kind of open source this and come to kind of a collection of ideas of how to do it and get everybody on board and, you know, make that interface as generic as possible, log someone in, log someone out, and not embed the business logic into it. The business logic is for what you and your customers say you need to do. And how do we hook into Asterisk? Well, we hook into Asterisk using the ARI. At this point in time, we're just using Asterisk to bridge channels. Because to be honest with you, that's all we really care about Asterisk doing. Asterisk isn't at the core anymore, it's moving to the edge. You want SIP proxies handling the SIP traffic. You want databases doing database, web, Apache servers launching web. You don't want that in Asterisk because it's just another thing that you, being a telephony guy, need to worry about. So you just have Asterisk do bridging and go from there. So now bear with me because I don't have it on here. So how are we doing on time? I got like 10 minutes, I think. Okay. So basically, the way we did it was we broke it out into an API side, which wraps around the database in Redis, and then we broke it out into an application side, which your application talks into your Asterisk box or your FreeSwitch box or your Nortel PBX, or depending on how you're doing things. So that if you want to integrate it with something else, you just got to worry about the app. That, you know, the APIs, they push into the database in Redis, and you shouldn't have to change those. If you do, you just extend upon them and you move it out to something else. So basically, we've created kind of two little projects. We've created the core API side, the server side, and then I've just quickly wrote a simple Python client that's going to use the APIs to do all the provisioning. Like, this could be a web, this could be whatever, but I'm not writing directly to the database. I mean, these are just, you know, basic concepts, but nobody's really pushing to have that atop of Asterisk. And I really wish some of you were at DevCon that we had 2 days ago, because the big question was, now that we have Asterisk 12 out, who's doing AppQ? Who's gonna do that? And basically, the consensus was, well, AppQ is going to be done, but it's going to be done on ARI. It's not going to live in Asterisk. So it's kind of a moot point. If somebody wants to go and do an AppQ on top of ARI, that's cool, and, you know, get an open source, but nothing's going to ship with Asterisk, or it shouldn't ship with Asterisk, because moving forward, that's not the point of Asterisk. It's just a simple engine, and you don't want to embed those apps in your engine. So yeah, so basically we have three concepts. We have the concept of a user, which at this point in time, it lives in our database. But to be honest with you, I don't think it should live in our database, because we're a queue. We don't need to worry about users in that concept. So we'll hook into, ideally, an LDAP or an existing user auth source. But we need that user auth because we did it multi-tenanted. So you can see there's two users. There's me and Jared. Jared Smith is, we've already talked about some ideas of what we'd like to see kind of going forward with it. So we create a user. Again, you can create it in the database, or you can create it in your company infrastructure. But we create we create agents in our app, in our database, in our queue app. But again, we don't want to tie personal information, because, well, if the agent leaves or something, or you got to update a password or stuff like that, you got to push it multiple places. So we don't worry about that. All we do is we just link them somehow. So agent, bear with me. So agent, yeah, so we go agent add 2, and 2 is Jared. Oh, hold on. I had this working. This is going to turn into like a little David Lee thing yesterday where it didn't work right off the bat. Add help. ID 1, ID 2, ID 1. Well, add 1. Well, I can't figure it out right now, but imagine it added it in, and it works. Because the reason it works, I'll go back here. Does anybody use talks in Python? It creates a virtual environment. Now this might go out and hit the web and all that good stuff, but we've wrote unit tests that that exercise our REST APIs. So right now we have 63 tests that go out and we create users and all that stuff. So even if we start changing it, we're hopefully going to catch it and go from there. So yeah, so we have the API server that runs, and we have a little client that goes on top of it, and we can see our queues, and we can add, and this is all real time. You don't have to take anything down. You don't have to reload Asterisk, because Asterisk doesn't know about it. It just takes a channel in and dumps it tries to dump it into a queue. Well, if the queue doesn't exist, we just 404 it back, and then you just try to deal with it somewhere else. So yeah, so we have the concept of users, but that's only needed when you want to get into multi-tenant, because you want to run multiple companies on your queue. So we have the concept of that, and you can list, create, and we've already gone out and kind of created these how it pertains to what our next customer wants to do. But that being said, it might not be the right way, and but I want to kind of get some collaboration with people to say, hey, this is a great idea, but we really don't want to do this. Same thing with agents. Agents are your people answering the calls. So again, data sets, we want to know when they were created. We want to know when they were last updated. Again, so you want to get a single agent because your browser, you want to see a specific agent, or you want to get a list of them. Again, this isn't new concepts, but from an app queue point of view, hopefully it is. And then you got your queues. So we have callers that join the queue, we have members that join the queue, and then we have queue statuses. But I don't want to get the status information of that queue for the last 20 days, because that's a report, and the report should go through a reporting interface. But I do want to know what's the actual state right now. I got 32 callers in my queue. Okay, I will just return this because we go to Redis, and Redis just has a simple, we use sorted sets in Redis, and we're using their native functionality. So we just simply say, how many objects are in this list? And they go 32, and we just forward that on. Now we manipulate it and all that good stuff, but we're not calculating it. We're using native functionality in Redis, and it's super fast. Same thing with the actual matching. Right now we only do first in, first out, but to Redis it's a sorted set, so we just pop the guy off the top when an agent becomes available. So yeah, so we're not building any of this business logic, but that being said, you do want to build business logic on top of it. But so from that point of view, we're just going to kind of modularize it. We're going to say X, these are X, which is your caller and your queue, and Y, you're going to output who we match it to. And you're going to decide how we match it to. So like I said, we're just going to do first in, first out, because in Asterisk queues, I mean, how many people know that there really isn't the concept of a first in, first out in Asterisk? I mean, there is, but if you're listening to an audible prompt, you're never going to get matched to an agent because, well, you're hearing a prompt. But if you have your prompts playing too aggressively and the wait cycle between those prompts is 30 seconds, and your prompts are 15 seconds long, you're only going to get a snapshot of a X amount of minutes, like 10 seconds, to actually do a match to an agent when they become available. So you'll see, and we've seen this, your longest wait call keeps ticking up and up and up, but these newer calls coming in are getting answered. And it's just because of bad random luck, to be honest with you. So with Redis, we just pop them on the list. We don't care if they're listening to a prompt or not, because, well, the queue really doesn't have a concept of a prompt, because we just simply say via the ARI, hey, X amount of time has passed, play a prompt. And now because ARI, you can do all sorts of cool stuff asynchronously. We don't care if they actually finish hearing that prompt. We just say, okay, bridge the call, and away it goes. Now, I know I'm saying we do this, we do that, but we actually haven't implemented the ARI side of it. We have something going with AGI and fast AGI and async AMI and all this good stuff. But again, it's kind of hacky at best, because it's not designed to do that. So talking with Jared, and listening to Asterisk DevCon, for us to kind of really convert what we have today to the ARI is literally going to be a few lines of code, because we already have the concept of we answer and we play back. Well, we just changed that to a curl request to the AMI interface, and we just got to track the channel ID, which we already do today because we put it to a UUID and we stuff it into Redis. So yeah, so that's the idea, is take the queue out of Asterisk, because Asterisk really doesn't need to know about it. Just bridge the channels, and then have your out-of-band app or business logic control all that. Gone are the days, or gone will be the days of actually using DTMF digits to do stuff, because I'm sure a lot of people do. Use a DTMF code, you tell your agent use a DTMF code to log into Asterisk, and then you have to worry about pushing that off. Well, now you just simply click a button, they're logged in, or you transmit us how, this is more specifically how it works. You tell the queue app where the agent lives, either by a SIP URI, and as long as our gateways or our bridging Asterisk boxes can resolve that information up a layer into a proxy and then out to a PSTN and out to a cell phone, well, we can get it. But there's some limitations on device states, but maybe you don't need to do transfers and all that good stuff. You just simply want to go out and find your agent, have them talk, and then they hang up, right? So there's many ways to skin the cat on that one. So yeah, so that's, in a nutshell, basically it. So how does it look today? Well, it's open source. We want to open source this app. We want it to go on app ARI, or not app, we want it to go on ARI. It's Apache 2 licensing, because we use a lot of other external libraries that are under Apache. And basically, like that's basically my talk. So it's more of a cheerleading thing of what we're doing, because we have a customer that's driving towards that. And at the same token, we now have ARI that's going to be able to do that. But we need work now, because ARI is so new, we can't throw that into production right away. So there's going to be some uptick to make sure it works and stress that interface. But from the Q app, it's rock solid, because it's Redis and it's fast. The only thing we need to do is just kind of expose new ways we want to control Redis. And I'm sure there's projects that wrap directly into Redis to do that, but it was more of a learning experience for myself and the team that we got back in Ottawa to kind of understand Python better more, and like just a development effort and learning experience. But talking to a couple people here, I mean, they see a lot of potential in it outside of what we've seen for our customers. So I think there's a really good chance that if this thing plays out well, we could turn this into the de facto app queue of Asterisk that people use, and then people build atop of it for their business logic and their call center, the CRM integrations. I mean, again, to be honest, we don't really care about the CRM or the call recordings and all that stuff, but we want to make sure that they have access to that information to do whatever they want with it. So I think that's what we're trying to do is we want the sorting and we want the matching and all that good stuff, but we want to make it easy for people to come in and consume our resources and our data to build reports on it, because it's very difficult to build business logic into it and then have a new customer come along and say, yeah, that's really cool and all, but my concept of a longest wait call is longest wait call for the first 15 seconds. And then after 15 seconds, it's called something else. And we use Erlang to calculate it, and we don't. And Asterisk kind of has some of that built in there, but it's very difficult to change and all that good stuff. So yeah, so that was me rambling on. So I guess we're done, or we got a couple minutes for questions, or if you, no questions? Well, we'll do the guy in the back, because I know you and I don't know him.
Hi, good morning. Well, great job, by the way. Just a simple question, but what I found, what we currently use, and it doesn't work very well. Does this manage multiple agents in multiple queues at the same time?
Yes. So again, to us, a concept of a queue is a sorted list. So we simply take that information in, and then we calculate it, and then we match it up. But how do you calculate, what's the matching priority? How do you know, if you have two people that come in to a queue at the same time, what's your use case for actually matching them up to an agent?
Correct.
Right?
So in other words, when a call comes in and, one agent is logging to, say, a support queue and a sales queue at the same time.
Yes.
Right? So how do you distribute the call appropriately according to a certain ring rule or incoming rule that was determined in the queue?
Well, we don't. We build it as a little module that will allow us to determine what that match is. So we get everybody in, and then you would tell, like you tell me or you tell the app how you want to match it. So you can do it by weights. Like you can weight your queues. You can say, support queue is higher. I want those guys to be answered, but I want 5 to be answered, and then I always want the 6th one to be out of the sales queue, so you're never overflowing. So that matching, that business logic process is not in. We just simply say, configure it for, your match process, goes into this little module. We'll give all the available agents as a list. This is what you can pick from. This is the algorithm to match with. Spit out who the match is. So, and when it spits out, then we take the responsibility of passing it along to have Asterisk do the dial to connect them.
Okay, got you. And just one more little question, if possible. What sort of scalabilities have you come in real life with this so far? For example, how many boxes, how many agents at the same time, how many concurrent calls, and so forth?
Well, we have a couple unit tests that go up, and we can spin up like 1,000 agents and put in 10,000 calls to match them all up. But there really isn't a limit because we've done it in a way that if you run out of a resource, because
just add more.
Yeah, you just add another. You spin up something else to handle it. So if you're overloading your web server because you have a lot of socket connections, well, just proxy your web servers together. If you're scared that Redis is going to die because whatever, well, you kind of cluster them. I know Redis doesn't have clustering.
Yeah, you just deal with it on its own, right?
Yeah. Yep.
Okay.
So you just keep adding this way.
Sure.
Like, that's the idea. This way, no longer this way. Okay. And that's how we kind of did it from
Thank you.
The first step. No trolling. No trolling.
I promise nothing. So I know ARI is very, very new, and you've basically got this working on Asterisk 1.8.
Yeah, 1.8.
So you've been using AMI and AGI as the interface to make controls and set up channels and such. So my question basically is, with ARI, is there anything that you've noticed so far that is lacking that would not allow you to take this as it is today and put it, say, on Asterisk 12/13?
I don't think so. Just last night I quickly hacked up something to get an ARI call in and dumped it into the queue. Haven't done the matching process. Talking to Matt Riddell, who's I think next door, who's actually doing a working demo of it, there's a scenario where we originate in a channel, but we don't get any information back telling us what that origination is. So we have to kind of go out and look for it. Yeah, so I think that's going to be a lot of the things moving forward is if everybody's going to use ARI, there's going to be growing pains, and we kind of discussed it, how do you handle it, but I don't think we're at the point where I can definitively say this is lacking, but I think in a week, once we go back and we start hammering at this, you'll see us on IRC Dev going, why aren't we getting this information? So, but yeah, segregate it and all that good stuff. Anybody else? Anybody write their own app queue? How's that working out?
It's all right. We still kind of dealing with scalability on the client side.
Yep.
Visual presentation because browsers don't process JavaScript.
Okay. Okay. Yeah, so the whole idea with this is fast. Scale it up fast. Everybody's virtualizing, or that's where everybody wants to get to. Bare metal's gone. You got guys that come and go in your company, or gone are the days of people owning that infrastructure. It's easy to spin it up and destroy it. And I think that's what, personally, I'd really like to see this concept worked as, is spin it up, use it, destroy it, and have it easily to share that information across. So.
Thanks, Paul, for the great presentation.